Hello student, I am Dr. Devaram, Assistant Professor, Department of Geology, Government Dungur College, Bikaner. I welcome you all in my YouTube channel. In the series of physical geology lectures, today we are going to discuss a very important topic of geotectonics, that is earthquake, a tragedy to life and property. भूकंप अगर हम बात करें भूकंप की परिभाषा की तो पृथ्वी के अंदर आंतरिक हलचल जो कि बहुत अत्यधिक मात्रा में ऊर्जा का उत्सर्जन करती है. An earthquake is the sudden vibration in the earth crust produced by the rapid release of energy, and this energy radiates in all directions from its source of origin, that is called as focus, and energy moves like waves. पृथ्वी के अंदर जो ऊर्जा होती है वो सभी दिशाओं में उद्गम से फैल जाती है और वो एक तरंगों की तरह बहती है. एक उदाहरण हम देखें, जब हम एक शांत पानी के स्रोत में कोई पत्थर फेंकते हैं तो उस पानी के अंदर तरंगे उत्पन्न होती है. ठीक इसी प्रकार जब पृथ्वी के भूप्रपटी में कोई डिस्टरबेंस आता है, विक्षोभ आता है, तो उसके अंदर हलचल होती है, वाइब्रेशन होता है और जो तरंगे होती हैं वो उसके उद्गम स्थल से सभी दिशाओं में गमन करती है. If we throw a stone in a pond of still water, a series of waves are produced on the surface of the water. These waves spread out in all directions from the point where stone strike the water. जहाँ से स्टोन स्ट्राइक करता है उससे सारी दिशाओं में वेव्स प्रोड्यूस होती है. ठीक उसी प्रकार अर्थ के अंदर भी आंतरिक हलचलों की वजह से जो एनर्जी रिलीज होती है और वो वेव्स के रूप में सभी दिशाओं में फैलती है. Earthquake constitute one of the worst natural hazards which often turn into disaster, causing widespread destruction and loss to human life. Earthquake occurs every now and then all around the world, except in some places where earthquake rarely. भूकंप लगभग वर्ल्ड के सभी भागों में अब आता है. बहुत कम ऐसे जगह हैं जहाँ पर बहुत कम भूकंप आता है. The devastation of city and town is one of the effect of earthquake. और जब भूकंप आता है तो जिसमें कई शहर और कस्बे जो थे वो डिवास्ट हो जाते हैं, नष्ट हो सकते हैं. भूकंप से रिलेटेड कुछ टर्मिनोलॉजी की बात करें तो हम सबसे पहला है फोकस या हाइपोसेंटर या केंद्र, या ऐसा पॉइंट जहां से भूकंप ओरिजिनेट होता है या उद्गम होता है, तो उसको फोकस कहते हैं या हाइपोसेंटर कहते हैं. So focus is the point on the fault where rupture occurs and the location from which seismic wave are released. पृथ्वी के अंदर ऐसा पॉइंट जहां से seismic वेव ओरिजिनेट होती है, वहां से भूकंप का उद्गम होता है, उसको उस पॉइंट को फोकस पॉइंट या हाइपोसेंटर या केंद्र बिंदु, भूकंप का केंद्र कहते हैं. दूसरा है एपिसेंटर या अधिकेंद्र. Epicenter is the point on the earth surface that is directly above on the focus on the surface, and the point where an earthquake or underground explosion फोकस के जस्ट ऊपर वर्टिकल सरफेस के ऊपर जो पॉइंट होता है उसको हम एपिसेंटर कहते हैं. नाउ isosysmal line, the line connecting the points of equal intensity on the ground surface. ग्राउंड सरफेस के ऊपर इक्वल इंटेंसिटी की जो लाइन होती है उनको हम आइसोसिस्मल लाइंस कहते हैं. समान भूकंपीय रेखाएं. सुनामीज. सुनामी एक जापानी शब्द है और जब समुद्र के अंदर फ्लोर में भूकंप आता है तो बहुत बड़ी गहन सी वेव जनरेट होती है और जब वो वेव्स सरफेस समुद्र के तट पर पहुंचती है तो उनको सुनामी नाम दिया गया है. सुनामीज आर गैंड सी वेव जनरेटेड बाय अर्थक्वेक ऑन द सी फ्लोर. समुद्र के तल के अंदर भूकंप आता है और वहां पर बहुत बड़ी बड़ी सी वेव जनरेट होती है और these waves cause heavy destruction in the area lying near the seashore. जो समुद्र के तल के पास के इलाके होते हैं, तट के इलाके, वहां पर बहुत ज्यादा जान माल का नुकसान होता है और उनकी जो वेवलेंथ होती है अप टू 200 किलोमीटर और 800 किलोमीटर पर आवर स्पीड होती है. Near seashore, they slow down and gather height of up to 30 मीटर and cause heavy destruction at the coast. तटीय इलाकों में कई बार उनकी हाइट 30 मीटर तक पहुंच जाती है और बहुत ज्यादा नुकसान करती है. The destructive waves are also called tidal waves. Results from the push of the underwater fault or undersea landslide. In open ocean, height is less than 1 meter. Or in shallow coast, water waves can be more than 30 meter. Or these are the very destructive again. So, if we talk about the formation of tsunami, then there is in the sea floor there is a displacement in the rock and waves are created, and then on the surface these are the sea waves are created, and the speed increases speed so as the towards the coast. This is the big waves of tsunami in 1960 in Hilo, Hawaii. Tsunami model, Alaska quake. Now, the wave produced due to earthquake. भूकंप के दौरान जो सिस्मिक वेव प्रोड्यूस होती है उसमें मुख्य रूप से दो प्रकार की होती है, बॉडी वेव्स एंड सरफेस वेव्स. पहली है बॉडी वेव. बॉडी वेव ट्रेवल थ्रू द इंटीरियर ऑफ द अर्थ as they leave the focus. Body waves are further divided into following types, that is primary wave and secondary wave, P wave and S wave. So if we differentiate between the primary wave and secondary wave, the primary waves are high frequency and secondary wave are also high frequency. Primary wave have short wavelength, secondary wave has also short wavelength. Then P waves are longitudinal, but the S wave are transverse. P wave can pass through both solid and liquid, but S wave are pass through only liquid. So cannot move through the liquid, pass through only solids. Move forward and backward as it compressed and decompressed. Move in all directions of their source. P wave is faster S wave is slower than the P wave. P wave की जो वेलोसिटी होती है वो फास्ट होती है और S wave की जो वेलोसिटी होती है वो P wave की तुलना में कम होती है. First P wave arrives. After P wave S wave is. पहले P wave अराइज होती है, जैसे P wave अराइज होती है उसके बाद में S wave अराइज होती है. दूसरी है surface wave. Surface wave travel parallel to the earth surface and these waves are slowest and most damaging. Surface wave are divided into two types, L wave or relay waves. Love waves and relay waves. Now, the recording of earthquake. Seismograph record the earthquake. This is an instrument, pillar supported, and there is a rotating drum. And as the ground is shaking, then the rotating drum is recorded by this marker. So, seismometer is the instrument that measures the motion of the ground, including those of seismic waves generated by earthquakes, volcanic eruptions, and other seismic sources. Seismometer may be deployed at Earth's surface, in the shallow waters, or in boreholes or the underwater. Now, how much bigger the surface waves are? P wave, S wave, and surface wave. So, P wave, S wave, and surface wave are larger waves and giant waves. Now, this is the graph from where we can find the distance to the epicenter. So, this is the first P wave arrives, and this is the first S wave arrive, and in between there is the interval of the P wave and S wave. We can find the distance of epicenter from the focus. So that is the time delay between the P wave and S wave. So on the basis of this interval, time interval, location of earthquakes and earthquake epicenter can be done. So this is the intersection of triangulation of three circles, and where all the three circles will be intersect, that will be the epicenter of the earthquake. Now, classification of earthquake. Then first, on the basis of their mode of origin, earthquake are of three types: surface causes, volcanic causes, and tectonic causes. So first we discuss about the surface causes. Surface causes include the great explosions, landslide, slip on the steep coast, dashing of sea waves, avalanches, railway trains, heavy trucks. Some large engineering projects cause minor tremors. Some of them are man-made and other are natural. कुछ मानव निर्मित होते हैं तो कुछ प्राकृतिक होते हैं. इस तरह से इन कारणों से सरफेस के ऊपर सरफेस कॉजेस की वजह से भी अर्थक्वेक आते हैं. दूसरा है वॉल्केनिक कॉजेस. वॉल्केनिक eruptions produce earthquakes. Earthquake may precede, accompany, and frequently follow volcanic eruptions. They are caused by sudden displacement of lava within or beneath the earth crust. There are two general categories of earthquakes that occur at the volcano: volcano-tectonic earthquake or long period earthquake. Third is tectonic causes. So structural disturbance resulting in parts of lithosphere is the main cause of this type of earthquake. Most of the disastrous earthquakes belong to this category and occurs in area of great fault and fractures. टेक्टोनिक कॉजेस की वजह से जो अर्थक्वेक आते हैं वो सबसे ज़्यादा भयानक या डिजास्टर्स होते हैं और ये जो अर्थक्वेक होते हैं ये ग्रेट फॉल्ट्स और फ्रैक्चर्स के एरियाज में जनरली आते हैं. Sudden yielding of strength produced on the rock of accumulating stress cause displacement, especially along old fault zone known as great transform faults. Now, if we understood understand the tectonic earthquake, then there is a mechanism of tectonic earthquake is explained by the elastic rebound theory which was given by the H.A. Reid. So explain how energy is stored in the rock. So rock bend until the strength of the rock is exceed. So this is the original position and this is the deform. So deformation start, there is the in the opposite direction forces. So rupture occur and the rock quickly rebound to the undeformed shape. So rupture occurs and the release of energy takes place. The energy is released in the wave and radiate outward from the fault. Now rocks rebound to the original undeformed stage. Here rock is rebound. So this is the elastic rebound theory given by H.F. Reid. Now second type of classification of earthquake is on the basis of depth of focus. First one is shallow focus earthquake in which focus is up to 50 km, 55 km. Second is intermediate focus earthquake, hence having the focus point is 55 to 300 km depth. And third one is the deep focus earthquake, that is 300 to 650 km depth of focus. The shallow focus earthquakes are more violent at the surface but affect a smaller area than deep earthquakes. Shallow focus earthquake ज़्यादा भयानक होते हैं सरफेस के ऊपर लेकिन बहुत कम एरिया को प्रभावित करते हैं, जबकि डीप अर्थक्वेक होते हैं वो बहुत ज़्यादा एरिया को प्रभावित करते हैं. 95% of energy released by earthquake originate in narrow zone that wind around the Earth's surface. This is the zone where the most world's 95 earthquakes are the originate. Earthquake depth and plate tectonic setting. The earthquake in the subduction zones. Earthquake in the divergent boundary islands. And this is the all about the earthquake, and we will discuss somewhat more about the earthquake in the next lectures. Thank you.